Hello everyone, welcome to Pepcoding. So today in this video we are going to discuss a question that is the variation of the previous question, that is burning tree 2. So what is this question actually asking us? It is going to be same as previous. Let's say what we have discussed in let's discuss that what we have seen in the previous video. In the previous video, we know that we were provided with a binary tree and a node where the fire will start. Let's say at I. So as we have discussed that from I, the time taken by the fire to reach to the next node, that is to its neighbor, is 1 second, right? Also in the previous video, what we had to determine that if the fire was the fire was started from the ith node, then what was the maximum time taken by the fire to reach the whole tree and to burn it down. So in the previous video, for the previous question, what we need to find? We needed to find maximum time to do what? To burn the whole tree. But now in this question, we need to find that at which interval which node was burned. Example, at 0th second, if this I was burned, we have to give answer as we have to create an array list, or let's say an array that is going to store this answer as I. For this J, what will be the time? Let's see that how the time is going to be calculated. If we start from here, for J, it is going to the fire is going to reach in 1 second. For K, it is also going to reach in 1 second. For N, it is going to reach in 2 seconds, and for O, it is going to reach in 2 seconds. So let's side by side create our answer. For 1, the fire is going to reach to where? To J and I, J and K, right? To J and K. Now similarly, for 2, the fire is going to reach till what? Till N and O. But this is going to be only for this tree, that is the tree below the I. Now in the previous for the previous question, we had discussed we have already discussed that if the fire spreads to its parent, then that child is sent as a blocker node. That is, here we are going to actually use 3 concepts. One concept is find node to root path, second concept is scale level down, and third concept is blocker nodes concept, that how we are going to use this blocker node concept and how we are going to traverse through whole tree. So we have discussed this in our previous video, so we are not going to discuss that concept again here. So if you are not clear with those concepts, I'll recommend you to go and watch previous 2 videos, because this concept is really important for this question also. So what actually is going to happen? If the fire reaches to G, the fire is going to reach in what interval of time? In 1 second of time. So in this one, we already have this array, or we already have a storage where we are going to store what? We are going to store the burns, the nodes that are going to burn with this interval of time. I'll call this as, instead of this max time, I'm going to call this as time, right? Now from this G, I send it as blocker node, which means that this I and its children has been already burned down. Now G has to look for its other children's, and the fire is going to spread through what? Fire is going to spread through G to H and L and M, right? It is not going to go back to I. So from G to H, it takes 2 seconds, and from H to L, it is going to 3 seconds, and it is going to take 3 seconds from H to M. So we are going to add this thing first. For H, we are going to add this H in 2 seconds. Now there is no storage for 3 seconds, so we are going to create a new storage, and we are going to add this, and we are going to add these 2 nodes, that is L and M. Why L and M? Because we are going to first make a call to left child, then to right child. Therefore the order is going to be something like this. Now from here, G is going to send fire to its parent, that is C, in how many intervals? In which interval of time? In 2 seconds, and this is going to be sent as blocker node. Now from C, as C is being burned down in 2 seconds, it is going to be added in this in this array, or let's say in this storage. It is going to store here. Now from C to F, the fire is going to spread in how many intervals time? It is going to store spread in 3 interval of time, that is in 3 seconds. So for 3, we are going to store F here. Now similarly, this is going to spread fire to where? To A, and it will be sent it as a blocker node. So from C to A, it is going to take 3 seconds. So we are going to add A in this 3-second storage. Now from A to B, it is going to take 4 seconds. So there is no 4-second storage. So we are going to create a new storage of 4 seconds, and we are going to add this B. Now similarly from B to D, it is going to take 5 seconds. We are going to create a new storage, and we are going to add this D. And from B to E, it is also going to take 5 seconds. So we are going to add this here. So finally our answer is going to be something like this. It is going to be something like various storages. We can call them as arrays. So various arrays of consisting the nodes burned with their respective time, right? For 0 second, I was burned. For 1 second, J was burned. For J and K was burned. For 2 second, NOHC was burned. For 3 second, LMFA was burned, and 4 second, B was burned, and 5 second, at 5 second, D and E was burned. So in the previous question, what we need to what was the required answer? The required answer was just this 5. But for this question, we are required to print this whole arrays. So what I can do, I can just create another array, right? Let's say that array is going to be at 4K address, and obviously these arrays are created separately, therefore they are going to have some address. Let's say 10K for this 0, 11K for this 1, 12K for this 2, 13K for this 3, 14K for this 4, and 15K for this 5. Now in the end, what we are going to do, we are going to just add all these arrays in this 4K. So it is going to look something like this. It is going to be a 2D matrix. So how it is going to look? It is going to be something like this. Sorry, there is going to be an array just for this case. I'm just telling for this case. It is going to be an array of 5 length, 2, 3, 4, 5. So it is going to be 0, 1, 2, 3, 4, and 5, right? Array of 6 length with 5 indices, okay, starting from 0. And it is going to store this is going to be at 4K address, and it is going to store address of these arrays, that is 10K, 11K, 12K, 13K, 14K, and 15K. This is what we have to do. So I hope this is simple. What we are actually going to do, we are going to use the whole code, that is the whole concept from the previous 2 videos, that is from previous 2 questions, that was finding node to root path, and K distance away, and K level away, and also this is going to be a new thing, that we have to just add something in the array list, right? And obviously the burning in the burning tree question, we have seen that how we are going to use all these functions together, right? Now let's start coding this question. And with this, after coding, you'll get to know that what actually, there is only a slight 3 or 4 lines code change, and with that all the whole question will be solved. So let's start coding. So let's start coding this question, and the whole question, the whole code is going to be same as the previous question, just we are going to pass a extra argument, extra parameter, that is going to be our array list. So for this, let's create an answer array list. Let us array list of integer type, right? And let's name it as answer. New list right? Now we are going to call a function, let's name it as burning tree, burning burning tree. And in this to this function we are going to pass three things. What are those things? That are going to be, first our root, second is going to be our data. This data is nothing but what? This data is nothing but fire node. So let's store it in something like int fire node is equals to data, and we are going to send here what? We are going to send our fire node, and this tells us that where the fire had started, where was the first initial point where the fire was started, and we are going to pass our array list answer, and from here we are going to return answer. Right, now we are going to create this burning tree function. So that is going to be public static int. I'm going to copy this thing, I'm going to paste here, right, burn tree, and here what we are getting, tree node as root, int fire node, and array of array, that is our answer. Right, now here what we are going to do, we are going to, let's say, make a variable of left time. It is going to be same as the previous question, that is node to root path. So we are going to, let's say, create a variable of left time, and we are going to make a call to burn function burn. We are going to burning tree, we are going to call this function, that is going to give us what? That is going to give us the time to burn the left subtree, time taken to burn the right subtree, right? So here it is going to be root dot left with fire node and answer as it is. And similarly we are going to do first return -1, and we are going to do this thing for right time. We are going to send right root dot right, and in previously what we did, if there is an answer, that is left time is not equal to 1 -1, which means there is some answer, that is there were some nodes that have been already burned from the left side. Okay, so what we are going to do, we are going to call a function, let's say burn, and we are going to pass this. What we are going to do here, we will just see in a little while. Say if right time is not equal to -1, then we are going to do something, right? These two things are written here. We are going to call a burn function, right? We are going to make a call that what actually is going to be written here in burn function, we are going to write afterwards. First see what will the base case is. First base case is if root is equal to null, for return -1, and if root is root dot data or root dot val is equal to what? Is equal to fire node, then we have to do something. What we have to actually do, we have to call a burn function, and here we are going to pass what? We are going to pass this function, first the root, the current node, then second thing we are going to pass it as time, that is initially the time taken is going to be 0. Second thing, the null pointer, this null initially states that this is the blocker node. The initially for this I, initially the blocker node is going to be null, because the fire is going to spread to its children, not to its parent. When for this G, it is going to be, blocker node is going to be as I, because the fire is coming from I. So here we are going to pass null and we are going to pass answer array, and from here we are going to return 1, right? Now let's write this burn function. So it is going to be void burn. We are going to get tree node as root node, then we are going to get a time, then what is going to be there? It is going to be a blocker node, so tree node blocker, and then what we are going to get? We are going to get an array list of answer. So I'll just copy this thing and paste it here, right? Now what is actually going to happen in this burn tree function or burn function? Actually this is going to return us the time taken to burn this thing and to burn this thing, right? So it is going to return us that. So for that we have seen that what you used to do, you used to make a call to what? Root dot left, that is to left child, with time as 1 increase, because time taken from here to here or here to here is going to take 1 second, that is 1 second more than previous time, right? So now third thing is going to be a blocker node, that is going to be same as blocker and answer array list as it is. Sorry, it's going to be answer, and for right we are going to do the same thing. Now here we have to do something, and that is going to actually return us this answer, that is actually going to make our required answer, that is this answer, that is going to be something like this, right? This is going to this formation of answer is going to happen in this function. So what it is going to be? The first thing is going to be simple, that if my root is equal to null, do what? Or second thing, or if my root is equal to blocker node, then just return from there, right? Now second thing what we are going to do, this is the main thing, if my time is equal to the size of my answer, that is answer dot size, if my time is equal to my answer size. So initially my time was what? Initially my time was 0, right? And size of my, this is my t, and size of my answer was what? This array list was empty array list, so size was 0. So if these two are these two things are matching, this means that there is a probability that we have to add something here, right? We can add something here. So let's say I'll show you what we are going to do. We are going to just create a new array list and we are going to add it here. So answer dot add what? New array list, right? This is doing what? Sorry, this is actually doing what? Actually, if there is a, sorry, if our answer is empty with 0 or some nothing, and our time is also 0, right? So size here initially is what? Size is 0. So if these two things are equal, that is size of the array list and my time is equal to are equal, this means that at this particular interval at time 0 there was some there, and if my loop was not terminated, if my this recursive function is not terminated, this means that at this particular time, at let's say for 0 second, there was some element, some node that was burned. So I have to store that burned node somewhere. So this is what I am doing. I am just creating a new answer array list. Let's say address of this was this was 4k. I am going to create a new array of 10k and I am going to just append this here. That is, answer is now going to look what? Answer is going to look like something this 5k or say 10k. with size what? Size with index as 0. 10k is going to stored at index 0 of answer with size. Size of this answer is going to be 1. So I hope this is clear to you all. Now let's see what we are going to do further. Now I have created this answer array list. I have created this 10k array list or 10k array. Now I have to store the position or store the value of this root. What I'm saying, I have to store the value of this root in this 10k, and then I am going to add this in my answer. So this it will give. So with this it will give me my final answer. So what I am actually going to do, at answer dot get at index 0, I am not going to write at index 0 because currently I am at which index? At time index. So instead of writing idx or passing one idx, I can just write here as at time dot add what? Root dot val, right? And with this it is going to fill my array and it is going to return to me. Let's try to run this code and see if it is giving us the segmentation for or any kind of errors. But this is actually going to be our final code. Okay, there are some error. What are those errors? Cannot find symbol. Okay, there it is. Let's see. It is saying that it cannot find this symbol. Burn. Everything is right. Oh yes. Before submitting, we have to complete this function also. That is, if my answer comes from some answer comes from left side, then what we are going to do? We are going to call this function. This is going to be same as the previous function or previous question. What we are going to do? We are going to call this with the root. Then what was the second thing we have to pass? We have to pass the time. Time is going to be what? Left time. Then a blocker node, that is going to be root dot left, and that's the last thing was going to be answer. And what we have to return? We have to return left time plus 1. We have seen that why we are doing this, right? Now second thing, what we are going to do for the right thing, root right time root dot right and answer and right time done right time plus 1. Now let's try to run this code, see if it is working properly or not. So it is being accepted. Let's try to submit this code. And it is giving us the correct answer. So therefore, I hope the question was clear to you all, and the solution was also clear to you all. What we did was has been already discussed in the previous 2 videos, that is find root node to root path and in the burning tree 1 question, and it is just a little variation of this question, that previous question. What we had to do, we had to, in the previous question, we had to give the total maximum time that is taken to burn this whole tree. But now in this question, what we need to give, we need to pass, or we need to give the nodes that are burned at that certain interval, right? So this is the I hope the solution was clear to you all. So thank you for this video. Let's meet in the next video.